Hi, this is Mrs. Verbal. This is Chapter 14, Mixtures and Solutions. This is Part 3. So in the previous slides, we looked at classifying mixtures and solutions. But last video, we looked at concentration. Now we're going to look at what we call solubility. So I have a beaker here that is full of oil and water. And if I take dye and I add a couple drops to it, the interesting thing that happens is the dye, it actually ends up going into the water portion. And I'm just going to stir it real quick here. So I don't know if you've noticed here that the oil, which is on top, it has no blue color in it, but the water on the bottom, which has a blue tinge to it because of the food dye, it actually dissolved, or it was attracted to the color. So we're going to look at what we call solvation. And solvation, notice it's a process of surrounding the solute with solvent particles to form a solution. Solvation is also called hydration when water is involved. And it's essentially the attraction between two different materials. So with water, because it has a dipole, it's going to be attracted to crystals or materials that also have a similar or opposite charge. So here's an example of hydration. And please note, we have sodium ions. So sodium ions have the positive charge. They're going to be attracted to the oxygen side of water because opposites attract. And then here we have a chlorine ion, which has a negative charge. Notice that it's attracted to the hydrogen atoms that are part of the water molecule. So like I said, this is called solvation or hydration if it's water. Here we have a molecule that contains a polar bond, so ethanol. Notice that ethanol, it is soluble in water. So if I took alcohol and I poured some of it into the water, it wouldn't form two layers like the oil and the water mixture. It would be essentially one phase, and that's what happens with ethanol and water. Here is petroleum. Now notice petroleum has no oxygen. It only has carbon and hydrogen. And as a result of it, it has different properties. So it's not like water. And there's a Latin term called SIMILA, SIMILIBUS, SOLVUNTUR. I apologize, I'm not a Latin student. Like dissolves like. And you may have heard this before in other classes. And it makes sense because something that's polar is not going to be attracted to oil. And I'll show you why. If you have ionic compounds, for instance, salt is an example of ionic compound, it's going to be attracted to the polar solvent. Here we have oil, and gee, this looks familiar. Notice it's on top. It's a nonpolar molecule, so it is not attracted to the polar substance, water, or ethanol. Now, say like you wanted to dissolve something, the question is, how much should you add and how fast? Well, you have to look at solubility. You have to look at, is it saturated, unsaturated, or supersaturated? We're going to do a lab where we look at those terms. And also the rate. Sometimes there are materials that take a long time to dissolve, and there's others that dissolve very quickly. So solubility, you're looking at the amount of solute per 100 mils of water. So when we do lab, you're going to see that we're going to be always comparing it to 100 milliliters of water. When you're looking at solubility, temperature is number one. You may have noticed in your own kitchen that some solids will not dissolve in a liquid if it's too cold, and that's the case. surface area. So if I took a cube of sugar and I plopped it in water, it's going to dissolve very differently than granulated sugar that is not in a cube. And then stirring or shaking. I have in my stockroom a stir plate, and it has a magnet that I insert into the container, and that's constantly agitating or stirring the mixture. That way it actually helps to dissolve. Okay, we have what we call unsaturated, and most of the time we're dealing with unsaturated solid or solutions. So it's less than the maximum. You can still put more solute in the solution. Saturated, you've kind of hit the level or the amount of the maximum. So saturated solution, it's fully dissolved, and if you put any more in there, there might be a problem. And then there's supersaturated. Now you can have situations where it is supersaturated, and what happens is it's actually more than the maximum. You're kind of playing with materials when you have a supersaturated solution, and I believe I have some examples of demonstrations that I can do with you that show supersaturated solutions. They're pretty amazing. So it's more the maximum solute that should be dissolved. Now, when you have a supersaturated solution, you can add a crystal or a piece of dirt sometimes, and it actually will cause it to be saturated. And it's unbelievable when it happens. It's a very instantaneous process. Like I said, I'll have some demonstrations, I believe, that I can show you about this. Okay, so this diagram or this chart that you're going to see probably on your quiz or your test, they're looking at solubility. So notice that we're looking at per 100 grams of water. So it's the same as 100 mils. And then we're looking at temperature. When you see something increasing, the question is the solubility, is it increasing or decreasing? If the numbers are going up, solubility does increase. Now there are situations where solubility will go down with temperature. So there's this material here where the solubility is actually decreasing with temperature. And typically that happens to gases. So saturated solutions have more than the maximum amount. And it's actually in an equilibrium state, so it's dynamic. It goes from one state to another readily. And these questions we'll get into more details in class. Okay, so here is a chart that shows us the different solubilities, and chemists do typically look at these kind of charts when they're making solutions. So notice if for some reason the solubility decreases with temperature, you're probably looking at a gas. So these last three here, these are all gases, and whenever solubility decreases with temperature, that means temperature is increasing. It's most likely a gas. The reason why is we have what we call Henry's law. So if something is hot, if it's a liquid, it's going to be harder for a gas to dissolve. When I make my soda stream, I typically use a low temperature water, something that's chilled, in order to dissolve a gas. You could affect solubility with pressure. You may notice when you open a container that has a fizzy liquid, there was some pressure that was being contained in that container in order to keep it dissolved. So the moment you open a can of soda, you're allowing the gas to escape or to come out of solution. So there's what we call Henry's law, and with Henry's law, we're looking at the solubility of a gas in a liquid. So it actually is related to pressure. So this is the formula that you will need to know. So notice that you have solubility 1 divided by pressure equal to solubility 2 divided by pressure. So you'll have 3 of these variables, and you'll be solving for the 4th variable.